My name is Tagani Lagasa from Hausa University School of Public Health. Um, we will see forecasting COVID-19 with SIR model in Stata. Um, we will see the theoretical description of SIR model and its application and interpretation in Stata. SIR model is an epidemiological model to understand the spread of an infectious disease. SIR stands for susceptible, infected, recovery, or removed. Before applying or using SIR model, there are four basic assumptions that should be considered. The first assumption is that the disease should spread from person to person directly without needing any vectors and so on, like mosquito. The second assumption is that the population should be constant or closed. That means SIR model will not consider the migration into account. That means whether in migration or out migration. The third assumption is that the population is homogeneously mixing. That means the population shouldn't be systematically classified or stratified based on age or sex or any other characteristics. The fourth is the recovery or death should be constant. That means reinfection is not considered in SIR model. When you see SIR model in details, a SIR model has susceptible compartment, infectious compartment, and recovery or death compartment. When you say susceptible, the group of individuals that are not infected with the disease but can able to catch the disease. The infectious compartment is a group of individuals who are infected with the disease and that can able to transmit the disease to the susceptible groups. A third compartment is recovery or days compartment. This group of individuals are recovered from the disease or they are dead because of the disease. The other most important elements in SIR model is that the parameters that control the movement of individual from susceptible group to infectious group called beta and from infectious group to recovery or days compartment called gamma. Beta means that the probability of an infected individual that can easily transmit the disease to a contact or susceptible in a specified period of time. Second, gamma is a rate an infected recovers and moves into the resistant phase. That means the average duration of recovery on each day. Now we will see the installation and use of SIR model in Stata. So that to install AP models or SIR model in general, you can easily write SCC install AP models. So that by saying this, you can easily install by clicking enter. You can easily install the AP models package that have SIR model and SIR model in it. So that I already installed the EP models package so that I don't want to install it for second time. After installation of the package, to use the SIR model, you can easily write db ep underscore SIR so that then you click enter so that the dialog box will appear as you see on the screen. So here there are four elements here in this dialog box. The first parameter is the model parameters that contain the values for beta and gamma and the initial conditions that contain the susceptible, infected, and recovered groups. And the third element contains the number of days that we are going to forecast or predict the disease and the day zero. And the fourth one is the about graph, whether if you want the graph or not. If you don't want the graph, you can suppress by clicking here, or you can color the graphs. Okay, now let's fill the data for model parameters. The beta value, as we defined beta earlier, it is a probability of an infected individuals will transmit the disease or infecting the susceptible group in specified period of time. For instance, an infected individual will infect a contact or susceptible in every 2 days, and the values for beta will be 1 over 2. So that 1 over 2 is 0.5, so that you can fill 0.5. And for gamma values, gamma is the average duration of recovery. Okay, so that if it is the average duration of recovery, for instance, if every day 30% of an individuals recover from the disease, then the value for gamma will be 0.3. Now let's come to the initial conditions. Here, the susceptible is the group of individuals who are not infected with the disease but able to catch the infection. So, uh, for new disease like coronavirus, the susceptible is not different from general population because every one of us is susceptible for the infection. So that the value for susceptible will be all individuals in general population for coronavirus. So that for instance, in our country there are around 110 million population. So that I will write here 110 million population. Until May 10, 2020, there are around 239 infected individuals, and there are around 99 individuals who are recovered from the disease until May 10. So that this is a parameter that should be fulfilled. When it comes to the calculations, the number of days is the days that you are going to forecast. For instance, if you want to forecast for 6 months, you need to write 180 days. Okay, and for if you want for 3 months, you can write 90 days. So the number of days will be determined by your plan to forecast or predict the disease spread. Now, day zero means that uh, the day before an index case. For instance, in Ethiopia, the index case appeared in March 13. That means um, March 12 was uh, day zero for the disease. So that I'll write here March 12. Okay. So I will click for clear data in memory because if I want to perform subsequent SIR model, you need to click this because the variables are already created in the memory, so that uh, before clearing, if you perform SIR models, subsequent SIR models, the Stata will not perform for you. It says the variables are already repeated, so that you need to clear the previous models from the memory. So that I will check clear data in memory. Let's come to the graph. So I want the graph, I don't want to click here, but I want a color. The color should be um, there, so that I will select S2 color 8. So I'll click model colors. So I fulfilled all the parameters, the important thing, so that I will click submit. So we need to wait until uh, the model is finalized. So here is the model, so that here as you see the susceptible is decreasing as time goes on from 110 million to 35 million in the 9th month. Infected also increased at the 5th month, but the start to decrease. That means at the 5th month it is the peak hours, the peak time for the infection. So here is the graph, will come later on. Now the recovery is also increased from time to time until 9 months. That means the end of forecast. So according to this estimation, the peak occurrence, the peak occurrence of these occurs at the fifth month in day 12. That means around 10, more than 10 million population will be infected during this day. Okay, so let's see the graph. The graph also shows that the susceptible will decrease as time goes on, and the recovery also increase as time goes on, and the infection also uh, become peak at the fifth month and decrease over time. So this is all about Tasir model in Stata. Thank you very much for your follow-up.